From deep inside the Death Star, I'm Chad Beater.
And I'm Andrew Richards.
And welcome to Defrag Tools and Build Week.
Build Week.
Build Week. We've got the big annual Build Conference coming up this week, starting on Wednesday,
Yep.
I believe it is.
San Francisco. Mendocino Center, whatever it's called.
And
the place down in Seattle. Down in San Francisco.
Down in San Francisco, not Seattle. If you're in Seattle, you're in the wrong place.
Yeah.
And you'll be doing a presentation there.
Yeah, actually, last minute invite. I'm doing top 10 store application issues, so crashes, hanging, stuff like that. Just going over roughly what we saw on Defrag Tools a little while ago about, don't miss having try-catch exceptions. Don't look at, always check for nulls and treat background tasks this way. And Martin, who writes co-wrote the Windows Runtime via C# book with Jeffrey Richter. He's going to be my co-host.
Oh, so, great.
It should be good.
So people can come on down, see you in person, get your autograph, because you're a big star now.
5:30 Thursday, so it's the last session before the party.
Ah, great.
So I'll keep it on time, so you're not late.
Yeah, you don't want to keep people away from the bar
Yeah.
for too long. They get cranky.
Yeah.
Or they start to just leave.
So and also the other thing we're doing is a Channel 9 live taping because of schedule and how tight it is. We're going to be live to tape and not live to air. And we're going to be taping that at 3:30 on Thursday. So if you want to hang around the back of the Channel 9 booth and
watch
yourself
watch that recorded in person.
Yeah, so that will be recorded at 3:30 on Thursday. Mark Russinovich is our guest, and we'll be talking about Azure mainly, of course. And then if you want to see yourself on TV, stand behind us, and then 9 a.m. Monday we'll post that one.
Come up and photobomb you guys.
Yeah. So no signs.
And it won't be like the Today Show or whatever that show is.
Well, you can do that if you want.
Yeah.
if you're that motivated.
Hi, Mom. Yeah.
If you're that motivated.
If your mom watches this show, and you could. Yeah. Anyway. Right. So that's going to be good. So last week on the show, we were talking about creating your own perfmon counters via the XML to do that and some of the code. So we're going to follow that up a little bit this week. How to compile it? Is that?
Yep. Turn the XML into something that actually does something
useful.
So yeah, you compile it. There's a tool. Where are we? Called the CTRPP, which is counter preprocessor. There it is. It's part of the SDK, so you need to look for. I've already got it installed, but Windows 8 SDK. This guy. Install. This is like a setup program you run to download the SDK. It's already installed, but what you want to do is install the very top one, which is the Windows SDK. Everything else is like the debugger and performance toolkit and all these other things. And the very top one is the straight Windows SDK, which gives you all of the tools and the compiler from the SDK. And that's where the CTRPP comes from. I always forget where it is installed to. I think it's x86 Microsoft Kits? Windows Kits.
Windows Kits.
They renamed it because it was Microsoft Kits for a while. There's 8.1. I just happen to use 8.1. And then CTRPP. So the CTRPP tool takes your XML file and turns it into code. Well, how do you make Visual Studio do that for you? On the CTR, is it on this page? Some page I was looking at actually gives you the MS Build XML that you can just copy paste directly into your project file if you want to do it the hacky way. The other way is just to do it via the UI. And what you do is in resource files is where I just made a console app here. Nothing really complex, just like Hello World type infrastructure, and it automatically gives you a resources folder. I added the man file that exists that we've made, and then what I did is you press Alt, or if you have the Visual C keystrokes, Alt F7, which is brings up the compilation property page. I'm not sure what it is, the keystroke, if you have a different default keystrokes, but I've been using Visual C since for, and quite frankly, I'm not willing to change my keystrokes.
It's stuck in your ways.
Yeah, stuck in my ways. So what you want to do with that manifest file is make a custom build, all right? And the command line is, and what I might do is copy all that and bring it out larger. Do all configurations because everything's going to be the same. And then what we want is a massive command line. And so what we have is the path to where that CTRPP is. I just put a hard-coded in my solution. And then it will spit out a couple of things. So these are the two files that it'll spit out. So one is the header file that you use to find out what the function names are that you're going to use. What CTRPP does for you, which is fantastic, is it wraps the whole initialization or performance library and just gives you a command called initialize. And you just call it and it does everything. It sets up all the callbacks and all this data mangling, all that stuff for you, all this hard stuff you don't have to care about. And the other thing it does is it compiles all those strings into a string table. And so -o is output, -rc is the RC file, resource compiler file. Because you want to have some control over the name, I'm setting the prefix, and so that way every function it makes, every variable it makes has this prefix on the front. That way it kind of gives it a nice unique, type world. And then there's the actual file itself. And so when you look at the command line, straight, it's just -o, -rc, minus prefix, some string. And you could have like an underscore on the end of here if you wanted to like kind of give it like word type cutting up. And then the actual XML file itself. So once you have that in here, what you can say is what files does it make? And so it spits out those two we just specified, perf H and RC. And you can see that, and because you've done that, the compilation order is known. So it will know that if I've modified the manifest file, it caused this header file to change. Because I caused this header file to change, I know I have to recompile this CPP file that called the header file. So it gives you that chain of dependency. The RC file is the important one here. So what I've done is I've included those in here as resources as well. Now the header file itself, I didn't really need to include, because by including it, you're actually making it compile, and you actually could right-click on it and say exclude from compile. It doesn't really matter with a header file because they're designed to be called over and over again anyway. What is important is the RC file is included, because the RC file generates a string table. Remember how we were talking about everything having a one offset?
Yeah. You had to do leave an extra space
gap
between each of your...
Yeah, so if we grab that 2012 example, that name requests, there's me calling request, and this is what the compiler has done, and if it's even annotated it with the locked keyword. It didn't do it for the description though, which is the one next to it, the 14. So the way I numbered these, I don't know if I made it clear that last time, is you start with an ID of 1. I'm not sure if it has to be one offset, but it's kind of obvious if you start that way. What I did is the 2000 level was this counter level, 1000 level this level, and then I said 1 is this bit here, this bit.
I see.
Right, so count ID 1, and that's how those were generated. So ID 2, that's how that was generated. So if I got to, say, if this was up to 12, then this would be 2, 1, would fit in there. So that way I could have 100 counters fitting in this one space. So I'm using the bottom digit to represent the name and the description, the next 2 digits for the counter number up to 99. I think there's a limit of something. 168 just popped in my brain, but I don't know if that's right or not. But
okay.
But there is a limit of how many you can have, and then I use the thousands for the level. So make sure I undo all that. So when you compile, all these files will be generated. So what I'll do is clean everything. And so if we look at the local hard drive now, all we have is a perf.man file. The perf.rc and the header file have been deleted, right? So obviously, as correlates to that, don't put it in source control, right? Because that's not going to help you. Let the compiler build it every single time. And then if I try to open these, it's not going to be able to find the file because it's not on the hard drive. There's no reason to actually have an RC file yourself. I actually just added it to give the some version details in the exe, but you could just exist with a string table, right? If you don't want to include, if you don't want to include the RC file as a file, what you could do is, these two, don't even have them listed in the folder, and then, under here, you could put a hash include. So you could, in here, instead, right here, go hash include counters perf.rc. So you can either compile it at the project level, which is why it's here, or you can do it at the code level, like that. So when you compile, you will see this string pop out performing. I type this string in, performing counter manifest build step. So when we compile, you'll see that right there.
Okay.
And because it's known that those header files and RC files are needed as a dependent, you'll see it happen sooner than later in the build process. It's not a pre-build step, it's not a post-build step. It's a dependent asset build step.
Okay.
So now we've got an executable. I'm just going to build everything, release and debug. So the next step is to run this thing. So the way you do that, where are we? I've got this batch file. The way that you associate or get the counters into the performance counter library is to use this command called load counter, LOD CTR, /m for manifest. It has lots of support for other things too, like ini files and lots of other things, a lot of legacy stuff. M is the new manifest way, and then a path to where the manifest file is. So when you deploy your app, you're going to need to do this. So you're going to need to deploy the manifest file with your application, and you would have it maybe if you had an install shield type approach, you would have it as a step in the install shield to extract the temporary file, run the command, and then clean it up. One of the things that that you kind of have to be aware of, which I'm not quite sure what the deal is with this, is there's a path to your file. And so if the file is on the path, like system32, that type of stuff, you can just have counters.exe, right? And this needs to match the file, obviously, that you're compiling to. If it's not on the path, you have to give it explicit. And I think it's kind of a way for the OS to go, I'm in Performance Monitor, what string resource table, or where is the exe with the string resource table to go look up the strings to view it in perfmon. And because it's not on the path, you have to say where it is, right? And so if you try doing this just with counters.exe and try to load the counters where it's compiled to in this release folder type of thing, it just won't work. And you'll be scratching your head why. And so what I've done with my reinstall script is I registered the manifest, which doesn't matter if you do it when or where, make a folder off the root called demo, copy the executable to the demo folder, and then in my case I run the program, and then immediately after I unload it. Now, in normal operation, you would just load it and that would be it. Because you are changing the manifest, you need the old manifest XML to unload yourself. So every time I run it, I'm making sure that I load the counters, run it, and then unload it. So when I recompile with a new XML file, I've got the ability to actually undo the damage, right? Because if they're different, it's not going to know how to undo something you changed because the file's wrong, right? So it's a good habit to be in. Sure, once your XML's stable and you're not changing the counters, just skip those steps. But But as far as when you're trying to get the counters to work
during your development process.
Yeah. Now there is actually a way around this, and it's a bit touchy. So I didn't have complete success. You can save and back up your configuration, right? I've had partial success with this, so I wouldn't rely on it personally. The other thing you do is you can rebuild it from the registry. So what happens is the counters get put in the registry as all these weird keys under perflib_v2. And what you can do if it gets in a really bad state is you can go in there, find the GUID. It's like, so at the moment, if we this is one I found out the other day. If you do asterisk or something and then tab,
yes,
it's a good way of filtering down.
Nice, a little feature of autocomplete that a lot of people don't know.
Aaron, my guest, has taught me that the other day. So I've got this registered, and let's say that I completely screwed it up and I didn't know how to. I lost the manifest file to undo the damage. I always forget where this is, so I'm just going to do a search. Oops, that was a whole string. This is going to find the performance library keys. And if worst comes to worst, what you do is you just delete the entire tree where this is found and then do a /R for reload. And because the keys are missing, hopefully it will clean up. But it's best just to follow the rules and do a load and unload of the manifest file that did the damage in the first place. So I'll put a link in the show notes about where this folder is since it's taking ages. So you've got it compiled, you've got it runnable. So that's and as you can see, we ran it, loaded the counters, copied everything into the folder, ran the app, and then this app, if I press a character, it stops. Then unloaded. All right. So what does the actual application do? Oh, I'm losing my voice. So when you start this app, what you need to do is actually enable performance counters in the first place. And the way you do that is you run a command called counters_perf counters initialize. And so what I've done is right at the top here, I've included the header file that's built, right? And that defines the function that we need. And then the initialize function is, there's cleanup in here. So he writes all this code for you, does all this magic, and gets you to the point where the library is running. Same in reverse. Here's the equivalent of the instruction. Here's the cleanup code. So
you should call this in your exit.
Yeah. And so one of the things to be careful of is because the performance library is not part of kernel 32, don't do this in DLL when you've got the loader lock. So don't do it in DLL main on attach or detach events. Or you can do it in detach when you're shutting down, but don't do it in attach, because you shouldn't be using anything that requires the loader lock when you're holding the loader lock.
We kind of had a show about that a while back where somebody had done that and was hanging login. Right?
So what I do is in real code is I go on the main entry point of where work starts. I go initialize, or if not initialized, take out a lock, initialize, and then close the lock so only one person does the work. In this case, what I'm doing is I initialize. Now, whenever you, even if you have your aggregation of the counter set to single, you still have to have an instance, because you still have to allocate a point where there's shared memory to read. So even though the name won't turn up in the list as a single instance, where the word single is there, no, single in the XML is there, this part here, you still have to make an instance. When it comes to single instances, just use a hard-coded name, right? Just call it my app, right? When it comes to individual instances, you're up to your own devices, what you want to do. In this case, I just use the exe name and my current process ID to make a string. And so each instance tells you the exe name it came from and the process ID. Perf create instance is from the performance library. By including that header file, it's included all the header files to get the performance library working for you. You don't have to add any additional hash includes up the top. This first value, the counters perf myapp, well, this is the prefix that I defined on the command line of ctrpp, and this is the name of the provider, right? It's concatenated together. Mm-hmm. This variable is defined in the header file that's compiled, right? That's where that comes from. Much like same thing goes here, is there is a GUID for the first counter set that you want to make. So if you have multiple counter sets, you'll be going through this instance creation multiple times. And then there's the string. So this string here comes from here. All right. Mm-hmm. So this is all the auto-generated code that you got. Once you have an instance, now this is where you have responsibility to hold a little bit of the data. I made this global called perf instance, and it is of type perf counter set instance, right? And it's a pointer to one of those. So you make an instance. Now, I haven't found any definitive documentation on this about whether you do or don't have to set the initial defaults. I erred on the side of safety and set them to 0 anyway, but I'm guessing it's going to set it to 0 by default anyway. But if you happen to have a non-zero default for some of these things, like you may, particularly when it comes to a cumulative type number, you might have a number that you want to set. Saying that though, the performance library can keep accumulation over history. So you can run and say, I'm up to 10,000 requests, and then stop, and then you'll say, all right, start again, and it will continue on.
Oh, it'll remember for you where you left off.
Yeah, and it's called multiple aggregate history is the instance type. Okay. And so if you did a set like this, you would destroy your history because you would be back down to 0. Right. So beware of how over time you get in the performance library to do that. The performance ones where we talked about on the 2 shows ago about the types, this one's got the word large in it, which means it's 64-bit. That one's large. Average timer is large as well by definition, and average base is just ulong, 32-bit, right? So when we look at the code for the sets, you'll notice that the first 3 are 64-bit, 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 and then the third one's 32-bit, all right? So be aware of that. So you'll find that these commands are very consistent. Is always performance handle, the instance handle, and then this magic number, which I'll do in a sec, and then a value you want to set. So whether it be a set or an increment, that's what they all look like. Now, what are these words here? Because I don't remember very easily these numbers, these IDs, right here. Actually, one here. This set, base ID is saying 4 is my base, right? So it's associating these two together. Because I don't want to have to remember hard code numbers in my code, what I did is right at the top here, I just made an enumeration that represents each of the timers. And I gave them names that are kind of, representative of the thing. And then I just started as, gave it as value 1 and had the numbers appropriate. So that way in my code, nice and cleanly.
Makes it a little easier to read.
Yeah, much easier to read. You know what you're playing with. So what this code does is it sets everything up, makes 9 threads. One of them will wait for 1 second, one of them will wait for 2 seconds, one will wait for 3 seconds, and that way at different cadences, they all get requests done at different times, and that's why on my performance graph you saw some nice, good spiky activity. If we run this, you can see it's kicking in. There's the 1's happening every second, the 2 happens every 2 seconds, 3 happens every 3 seconds. And the way that data is logged is up here. So here's the thread code. And so we need to log 2 types of information, just straight, pure, I am doing a request, and that's what these 2 are. So the loop says, the parameter was passed in with how many seconds to delay, and this while loop is just there just to make it go around infinitely.
Mm-hmm.
I record the start and end time, which we'll get back in a sec, and then here's the first two, just straight increments of the request. So even though I'm doing the increment exactly the same way on both, one has the effect in perfmon of a line going up and up and up in time.
My app.
And you can see the string I made there. So this is 3340. And actually what I can do is while this is running in the background, if I run two of them at the same time, and then if I just, I don't know if it will refresh if I, it will.
There it will.
I'll say all instances, so I'll get the total and the individuals. And so I can see if I sort by, for example, this one has done that many requests, this one's done less. This is obviously the second one that we've got made. But together, total, there's higher. So because I chose some in the aggregation, I now get a collection of the two. But when it comes, how many did I do per period, the line's roughly flat across all three. So I haven't, if the total was a sum, it would have jumped up and be 2x, right? Because there's two of them running. So I decided that this is a, how many requests per period am I averaging? But there could have been a sum version of that too.
Right.
When it comes to duration, you know, some people are, individually they're a bit spiky, but the average over the two is a bit flatter. All right, the average time for each call is 1 point something seconds or something. Oh, sorry, yeah, 1.6 seconds. So these two are just purely saying increment the number of requests I've had by one, and the other one is about that numerator-denominator situation where you want the difference in how long it took and then how many operations, which is one. The difference, it has to be in frequency ticks, and the way you do that is a command called query performance counter. It uses this large integer type, which is a 64-bit type. It allows you to have 64-bit numbers. I start it before the operation. In this case, the operation is a sleep for X seconds. I print out on the screen every time I woke up, and then I record the end of the operation. So the difference between those two, are, if those things have numbers, just for a bit of safety math here, I look at the difference. I use the quad part, do 64-bit math. 64-bit can be cast to U long long, which is perfect because that's exactly what this guy wants to see. Pass the difference in, and it's in a difference in frequency ticks. Happens to be 100 nanosecond units, and so this number will be quite big. And then how many operations, the denominator is a 32-bit number, and I add one. And then you can see how, with not much code, I mean, particularly with this one, right? These ones just 2 lines code, right? Right. You've got quite a complex mathematical thing. You know, repeat the XML 3 or 4 times for the max, the min, the sum, and the average. You know, copy this down 5 more times, and you've got a quite extensive graph.
It's doing a lot of that work for you, all the fancy math.
Now, one of the things that you can do is you can take this further. So this whole idea of duration, particularly like this one here, it's great to know what the average duration is, but what happens if you want to know, if you want to correlate it with other things? And so what you can do is you can use exactly the same metaphor of start and end times, but make ETW events that represent the same thing. And in Performance Analyzer, we've seen these graphs where there's like these little bars that represent work. It's kind of like the DNA views of those little square blocks.
Yeah, sure.
What we can do is we can also at the same time emit ETW, and that's what we're going to talk about next week. We're going to talk about how we do with this code where we are right now, right next to it, add ETW so that you can analyze it per instance. All right, everything's averaging 1 second. Why did this one take 15 seconds? It will be recorded, and we can associate with that event maybe the URL that was being processed or additional data, which
get a lot more richer data.
Well, we can't associate data with this, right? Or we can say it's a stat. We can't say, well, this was the file name, this was the request, this was the user. All that information can't be attributed to PerformanceMon. It's a good way of aggregating and knowing a statistical trend, but it's not a good way of analyzing an issue. And the code is very, very close to this. And so you can just put these guys right next to each other, particularly with start-stop. Right, where this query performance counter is, the very next line of code, you go event start, and the next line you go event stop right here. So as you're doing this work, it's very easy to plumb both of them into your code at the same time and get two different effects. Now with ETW, it's a subscriber model, so even you always emit the data, and ETW throws it away if nobody's listening. Where with Performance Mon, it's just blasting out. You don't have to have a consumer. Much like ETW with performance counters, nobody has to be listening for you to make the counters, right? And so they both have a very rich API that's designed to always be used, a very efficient API designed to always be used, and you don't have to worry about the consumption of it too much. So anyway, that's all next week. Enjoy Build this week.
Yeah.
See you Thursday if you happen to be there, 5:30 somewhere in some room.
Otherwise, people can catch it online here on Monday.
Definitely put comments in the show notes below. Tweet us at Channel 9 Live. We'll get those questions asked. Mark's on the air, so feel free to harass him with any questions that are more Mark-centric. And
Azure stuff. He loves Azure stuff.
Yep. And System Sounds, of course.
Of course.
And as always, enjoy your week.
Yeah, and if defrag tools at Microsoft.com if you have any questions or comments for us, stuff you want us to look at on a future show, we're always all ears. So have a good week.